Okay, we're studying IL-17 receptor and IL-21 receptor signaling on B cells. And the outcome, the main molecule we want to study is Bcl6. And the idea is that we already knew that IL-17 receptor signaling through NF-kappa B upregulates Bcl6. Other people have shown IL-21 receptor signaling upregulates Bcl6. And we want to see if they synergize. And in addition to that, we'll study germinal center response genes like ID2, and especially activation-induced cytokine-mediated AICDA, and its adectant class switch and somatic augmentation. These would require in vivo experiments. So what do? In vitro experiments, we just take cells, B cells, and let me show up here the types of B cells we use. We'll use B cells that we purify by the max columns, the magnetic column sorting from B6 to BXD2 to get their B cells. For other B cells, we use B cell lines, 70Z3, which is a pre-germinal center B cell, or A20, which is a late germinal center B cell. These are the B cells. We put those in vitro and we add either IL-17, IL-21, both, or neither. And we'll measure Bcl6. That's over here. And now, one thing that's important is to know the concentration. Sometimes IL-17 and different concentrations work in cell lines versus primary cells, like 10 nanograms per mil. Sometimes you have to go to 50. Schutau found higher levels of IL-17 work for Bcl6, which comes up in about an hour or two. It's a little later. So higher levels. But the problem is to see synergy, you don't want to use maximum levels. So maybe 20 nanograms per mil of IL-17 plus 20 nanograms per mil of IL-21 will show the synergy. If you just put in like 100 nanograms per mil of IL-17 and 100 of IL-21, it won't be any stronger than just 100 of either one. Okay, so that's the Bcl6 assay. How do we measure Bcl6? Well, like I said, that's a problem. Measuring Bcl6, that's down here in the main problems. Bcl6 is hard to measure. But what's done is you take different B cell subpopulations, like you do FAT sorting with FAS and GL70, and you take before you take the cytofix cytoperm, BD cytofix cytoperm kit, and you permeabilize the cell, and you use an antibody for intracellular Bcl6. Then you surface stain the different populations of B cells. FAS and GL70, you get germinal center B cells up as double positives. You stain with IgD and IgN, you get early development of B cells over here, IgD high and IgN low, and down in this region where IgM is higher, you get more mature cells. And we think Bcl6 should be higher response in the immature germinal center phase, and as you get more up to the mature cells, maybe more like plasma cells, you'll get lower ability to induce Bcl6. So you want to sort these two populations and look at Bcl6 expression. Finally, CD21, CD23, you get transitional cells, finally FO, MZ, and our special population, marginal zone precursors, which are in this region on the CD21-23 plot. And there, we know they have highest response to Bcl6. So that's by FAS. Also, once you got the populations, you'll do sorting. And you do sorting and you'll look at Bcl6 message, right, or real-time PCR, and if possible, do Western blot, try to look at protein. Okay, so that's the in vitro experiments. Oh, and we'll do confocal for Bcl6. So those are the in vitro experiments, one type. Now we do it in vivo too. We modulate IL-17, IL-21 using adenovirus that upregulates IL-17 and 21. And we do that in a B6 and BXD2 mouse. We also can specifically remove one or the other signal because we have the BXD2 IL-17 receptor knockout. We also have BXD2 IL-21 knockout, not the receptor. We need to get the IL-21 receptor. That'll take a long time in the background, but at least we're getting the highs. I think Alan Zajac or Laura Harrison has those. So we'll do the same thing in vivo again. When we do that, we'll sacrifice some eyes, intracellular staining, do the same sort of experiment over here for Bcl6 upregulation. And of course, we'll take some cells and we'll measure RNA, some cells and make protein out of. Some cells we'll do confocal. We'll do these, we save some tissue, we make slices, look at tissue and do Bcl6 staining over here. And finally, as I said, what's the consequence of Bcl6? Well, Bcl6 causes increased germinal center intensity, increased AICDA, increased class switch, and somatic hypermutation. Okay, for somatic hypermutation in vivo, we'll do these sorts of experiments, increasing IL-17 or IL-21 or both, but in the presence of NP-BSA, we'll immunize the mice, and we can look at the NP response at day 14 or day 10 to 14, and we just see if we have increased somatic augmentation, fast switch, in the presence of both versus one or the other. So this is the functional assay. Finally, I'll end up talking about the T cell. Just like there's a B cell development problem from early to late germinal center, and even the plasma cells, which BLIMP1 is high, which opposed to B6. There's a T cell blur. There's Th17s that we know produce IL-17. We think they also produce IL-21. Other people, but the problem is they have the transcription factor R gamma T. Some people think, well, no, that's not the way it is. It's really TFHs that produce IL-21 predominantly, and also those TFHs also produce IL-17. So that's a little bit of a question. So that's down here. When we study the mice, what we will do is also intracellular staining for IL-17, IL-21, gated now on T cells, to see if there are a lot of double producers, and that'd be intracellular staining with IL-17 and IL-21. You'll see some IL-17 producers only, some IL-21 producers. These are typically Th17, these are typically TFHs. But we think there's going to be double producers, and the question will be, what are these double producers? How prevalent are they? Are they really, do they have RR gamma T, so they're really Th17s producing IL-21, or do they have high Bcl6, indicating they're really TFHs producing IL-17? Now, so the two hard parts of this, Bcl6 is hard to measure, and the B cell phenotype is hard to identify. So those are some of the difficulties we have with this project.